Okay, good afternoon, everyone, and thank you for joining us on this Institute of Quarrying Lunch and Learn webinar. Today's topic is going to be all about improving your efficiency that Technidrive are going to take us through, and we're fortunate today to be joined by David Strain and James Chester, both directors of Technidrive. If you've not heard of the company before, they specialise in electric motors, industrial gear units and electrical automation to create industrial drive solutions for the quarrying industry, as well as a few other industries as well. We are hoping that we're going to get a number of interesting key takeaways from today's presentation on how everybody can help reduce their energy usage and their carbon footprint by also creating an intelligent, safe and more productive quarry. So I'm not going to steal any of David's thunder, and I'll let him take that away. In terms of questions today, feel free to drop them into the chat as and when they come into your mind, and we'll pick them up at the end of the presentation, but there will be time for questions at the end. So I will hand over to David and enjoy the presentation.
Okay, thank you. Thank you very much, and thank you everyone for taking the time to join in, and I hope there's lots of interesting takeaways, and as Sarah said, hopefully it will generate lots of questions, and ultimately I'm going to give you a little bit of an introduction to me, a little bit of an introduction to the company, and then I'm going to give 5 key takeaways for energy saving and to help us all with climate change and costs and everything else to hopefully make our quarries more efficient and better. So I'm going to go ahead and make a start. So first of all, a very brief introduction to me. Both a mechanical and electrical engineer. I have plus 13 years experience in industrial drive systems and design, and I have a passion for well-designed mechanical systems coupled with enhanced control to create energy efficient, cost-effective and reliable drive systems. We work with a lot of OEMs and manufacturers here in Northern Ireland and global, and we are experts in the motors, gearboxes for quarrying industry, recycling industry. We also get involved with food, water industries, a lot of industries, everything that turns, but we're quite strong in the quarrying sector and get involved with a lot of the end applications. Some of the global brands we represent is WEG, Bonfiglioli, Hitachi, Omron and Vega. Hopefully you'll have heard of them all. So a little bit about Technidrive then. We are a fairly dynamic team of 25. We represent leading global brands. We're bespoke drive specialists with the design capability. We have an 8 million turnover, and one of our major advantages is that we stock at the moment £2.5 million worth of stock. So we are one of the largest independent drive specialists in the UK, and we're not afraid to hold stock, which is a blessing at the moment. So our products include electric motors, industrial gear units, inverters, soft starts, PLCs, HMIs. We do completely bespoke automation solutions and level controllers. So just a little bit about our premier partners, which is fairly important to what we do. We have WEG, who is obviously a global company, and Bonfiglioli. I'd be very surprised if all of you guys don't have both WEG and Bonfiglioli throughout your quarries. Hitachi maybe not so strong in we have them for the VSD side. You maybe don't have so many of them in your quarries. You probably have Hitachi diggers in your quarries. Same company, but a completely different division that make VSDs. So it's a good product for us, one we've represented for over 20 years. Omron is another partner of ours. We keep Omron in stock, and then PowerDrive, which is our own brand of specific gears that we get manufactured to our own specification, and also the old quarry and shaft mount gearboxes, we bring them under the PowerDrive brand. So just to delve into that a little bit more, for WEG, we are a premier partner. We're the first premier partner in the UK and Ireland, which incorporates factory level support. That gives us access to the complete product range, factory level price support, factory level technical support, and joint marketing campaigns. The product range that we represent for them is electric motors, which everyone knows from WEG, VSDs, soft starts, automation, alternators, geared motors, and many other products. One of the unique things about this partnership is that we are able to give a 3-year warranty. And whenever we supply a motor along with the VSD, we know that the VSD, the motor's protected. We make sure that it's selected correctly. We make sure that it's installed correctly. And for that reason, we're able to give a 3-year warranty when the end product is tied together. And that's something that's exclusive to Technidrive and what we're doing. And yeah. The next one is Bonfiglioli. We are a Bonfiglioli Best partner, which is Bonfiglioli Excellence Service Team. And this partnership gives us the ability to have full product assembly. We have flexibility over our parts, means we can assemble from stock inside an hour. We've got factory technical assistance, product development, and we represent the industrial range and we represent the mobile range. It also gives us a lot of stock flexibility where we can change ratios from a very small stock, relatively small stock holding. We can build thousands of combinations of gear units, and it gives us that flexibility. In these parts alone, we have roughly 1.5 million in stock. It also allows us to be a service partner, which means that we can repair gearboxes. We tend not to repair gearboxes that aren't Bonfiglioli, but if it is a Bonfiglioli gearbox, we have all the parts and all the pressing equipment and everything in stock to repair. And the last one is Hitachi. We're a distribution partner for the UK and Ireland for Hitachi. In 1990, they developed flux vector inverter, which revolutionized the industry. And since that, AC inverters have all come on leaps and bounds. AC inverters is not necessarily just about control, but one thing we've always preached in Technidrive that AC inverters is about performance. And there's a big difference in a lot of VSDs out there in terms of performance, with regard to the amount of torque that they can produce in the motor, the speed range that they can be turned down to, some as low as 5 hertz, without the need for forced cooling. So there is Hitachi was one of the first people to develop flux vector, and for that reason we continue to use them today. They're a fantastic drive. Just want to introduce some of the customers that we work along with. I'm fairly certain that some of these guys will have plant in your quarry somewhere. All global manufacturers. We do a lot of drive selections for them. So whenever these guys are designing a conveyor, they'll come to us. We do the calculations for that conveyor, design in what ratio, what power we think should go on that conveyor, and ultimately the best way of mounting that conveyor. So we have a lot of experience in working with these guys and are proud to be partners with all of them. So on to our energy saving opportunities, and I'm kind of going to build up from the first opportunity being the least opportunity for saving to what I think is the biggest opportunity for saving. So energy saving opportunity 1 is simply changing out electric motors for higher efficiency electric motors. So there is regulations around this. The government is putting in things to force people to increase the efficiency, but other than just being forced to do it, there is advantages. So the current regulations from July 2021 is that all electric motors must be a minimum of IE2 from 0.75 kilowatt, and above are up to 0.75 kilowatt, and then above 0.75 kilowatt, they all must be IE3. So at the moment, everything above 7.5, it has to be a minimum of IE3 that is supplied or put into your quarry. Upcoming regulations, which is coming fairly fast in July 2023, which in terms of delivery times these days is just around the corner. That changes that 2-pole, 4-pole, and 6-pole motors between 75 and 4 kilowatt will be required to be IE4. So it's just that small window in the middle. These regulations are being enforced because 70% of industrial energy is consumed by electric motors. Therefore, bringing in any sort of regulations around that, if 70% of energy is used by electric motors, and we increase the efficiency of that 70% by 2%, it is a saving on energy, and it is something that all the governments is pushing towards because of climate change. That comes at a cost, obviously, to the end user of product. So I want to delve into just the efficiency that it will bring. This is quite small, but I wanted to get all the information on one page. So to give you an idea, I've just chosen a 75 kilowatt 4-pole motor. In an IE1 efficiency, that's roughly 93.5% efficient. So if we go all the way up to IE4, we improve efficiency up to 96, so roughly 2.5%. An IE3 is 95.2, and an IE2 is 94.4. These regulations probably started to come in roughly in around 7 or 8 years ago. So any motors that you have in your plant that's more than 8 years old, the likelihood is their IE1 are lower. And if they've been rewound, the chances is there'll be an efficiency drop with every rewind. So the savings then to be had, I have looked at operating 12 hours a day, 6 days a week, and I've looked at an energy cost of 15p per kilowatt hour. So basically, and I've used a purchase price of 3,800 for a 75 kilowatt IE4, and that looks at a payback time of roughly 2.68 years. So there is a payback, probably a lot longer payback than what a lot of you would expect or want. However, there is benefits and some facts down here. So the acquisition cost of the motor compared to the energy cost of 1 year is 8.66%. So buying the actual motor is a very small cost in comparison to actually running the motor. And the acquisition cost of the motor over its lifetime is only 0.43%. So it will only use, of the actual cost to run that motor will be, nearly, it'll only be 0.43% of the actual running cost. And it will only take 27 days for it to consume its acquisition cost in electric. So the advantages of this is it's a very, very easy change to make. So it's easy to replace. The new efficiency motors is all the exact same footprint as the old efficiency motors. It's the exact same specification. They can be controlled exactly the same. So you literally take one off, slot the other one in. The second thing is we all have to be accountable. And when the government bring in these regulations, there is no doubt that there is someone punching numbers in the background to say, this is the regulations we've brought in, this is what it has saved. So with this, it's very, very easy to quantify before starting a project. The third advantage, pumps and centrifugal loads are normally sized to absorb close to their installed power. That calculation I've just done, that's based on you using 75 kilowatt out of 75 kilowatt. most pumps and fans are sized that they will use their full power there or thereabouts. When it comes to things like conveyors, crushers, and things like that, they're normally not pulling their full load current. They normally have a lot of capacity in hand, and as the motor comes down, the efficiency comes down. So if you're only using 60% of your motor power, so on a 10 kilowatt motor, if you're only using 6 kilowatts, your efficiency will drop by 3 or 4%. So that's where you get into a scenario where, yes, you're putting on a higher efficiency motor, but if you're not using all of the power to that motor, your efficiency is dropping anyway. Another big advantage is it can be completed in stages as motors fail or replace, or as you're specifying new equipment. So if you have a manufacturer coming to put conveyors in your plant and you specify a higher efficiency motor, an IE4 motor, it will increase the cost, obviously, but it'll increase the cost as a small percentage. If you're replacing a motor anyway, I would advise to go for the highest efficiency motor possible, because you're having to buy the motor anyway. It's a small percentage more for a higher efficiency motor, and the acquisition cost of that motor is, as we've seen, it's only 27 days of the running cost. And one disadvantage is the predictions is based on 100% of full load current for both efficiency and power factors. And that's not often the case on conveyors, crushers, and screeners. So the savings would need to be adjusted down to what the motor's actually absorbing, as opposed to the plated power of the motor. Okay, energy efficiency saving opportunity 2. And that is replacing worm gear units with inefficient transmissions with high efficiency bevel helical units. So the savings here can be substantial. So first type of gear unit we look at is the worm reducer. So available in one stage, sort of from 7:1 ratio up to 100:1. It can go up to 10,000:1 as a combination unit, but the efficiency with every ratio is different. And as you get into the higher ratios, the efficiency drops like a brick. So for 100:1 worm gear unit, you'd be looking at 25 to 30% efficient, which is huge in comparison to what we were talking about before in electric motors, where we're saving 2 or 3%. So the next gear we'll look at is a helical worm reducer, which is a combination of both your worm unit and a helical stage. So the efficiency of this is slightly higher because you have the helical stage in the input, and it will vary from 44% up to 70% from ratios 100 to 20:1. The next one we look at is helical, which is your inline gear unit, and this is where we start to go up in efficiency. So they're available in 1, 2, 3, or 4 stage up to 800:1, and the efficiency varies from 92 to 98%. The next one we look at is bevel helical, which is very, very similar. It is also using helical gears. The only difference is one is bevel to get you that right angle configuration. That right angle configuration is widely used because it's very, very easy to slide onto your conveyor head drum, and it just suits a lot of applications for mounting. And it's the same, 2% per stage. So if you take something in a ratio 40 or 50, something like that, it's typically a 3 stage, which would make it 94% efficient. So vastly improved on your worm unit. So I've done some calculations here for comparison on that. So looking at a VF 250, which is a Bonfiglioli worm unit, and I've looked at a ratio of 60:1. I have taken the efficiency from the catalog at 76% efficient, and I have taken an A803, which is an equivalent bevel helical. And I've chosen application torque, which is what it all comes down to. There's a torque required for your application, and there's a power required to produce that torque. Everything in between is an inefficiency. So we want to make that process of getting that power into that torque as efficient as possible. So with an application torque of 7,000 Newton meters, the power required will be 24.1 kilowatts on the worm unit, whereas on the bevel helical, it will only be 19.5%. So as you can see there, the percentage is a lot higher than 2 or 3%. You know, you're saving nearly 15 to 20% efficiency in that one alone. In terms of kilowatt hours per year, your 22 kilowatt on the worm unit is going to use roughly 90,000 kilowatt hours in the worm unit, whereas it's only going to use 72,000 on the bevel helical unit. So there is big savings to be had there. Worm units have some advantages in that they don't run back. So on things like skip drives or winches or things like that, they can be an advantage where they won't run back, but they do come with that inefficiency. And certainly on things like conveyors, I would be looking to at some point make them bevel helical units. And certainly if any new equipment's coming into your quarry, I would be specifying to the manufacturers to put on bevel helicals. So the advantages of this opportunity is it's a large increase in efficiency in comparison to other initiatives. The results are quite easy to quantify before starting the project. So we can simply look at the catalog efficiency of the unit you're replacing, the new one you're putting on, the hours you're running, and we can calculate and quantify the results. The main disadvantage of this is that they're not like motors. Gearboxes is totally different across manufacturers. They're especially different across ranges. So your worm box is never going to have the same dimensions as your bevel helical box. You will have some similar dimensions, like you may be able to get something to match the shaft size, but 9 times out of 10, they will require mechanical modifications to the application. That will normally then result in more downtime to change that gear unit, which needs significant planning. So you need to be planning out to go to change that over a weekend or whenever you're down. But again, I would look to do it as things break down or age to the point that they need replaced, instead of necessarily taking off perfectly good working units. Okay, the third energy saving tip is what we call the square cubed law for centrifugal loads, fans and pumps. And this one, the savings around this is absolutely huge. It's been out there for years, advertised for years, since inverters have been adopted and widely used, but a lot of people still don't utilize it. So in this application, we've looked at a 90 kilowatt motor. We look at a saving factor of 1. The running cost for that 90 kilowatt motor in this one here, I've actually used slightly less hours. So I've used 10 hours a day, 5 days a week, which is roughly 2,600 hours a year. And again, 15p for electrical costs. And we're looking at running costs of roughly £35,000 to run that 90 kilowatt for a year. And then what we've done here is we've calculated them running costs of running on an inverter. So it has to be a fan or a pump or a centrifugal load, but if it is, we can use this thing called the square cubed law, which means that if we run at 90% speed, we can take 0.9 multiplied by 0.9 multiplied by 0.9, which gives us 72.9%. And that is the running cost of that motor. So it reduces, by reducing our speed by 10%, it reduces our running cost to £25,587. So in a year, that would save £9,500 in electricity. And that results in, I've roughly used a cost of installation of 5,900, including, that's more than the purchase price of the inverter. But that gives us a payback time of 6.2 months. So obviously that takes us into a window where we can really start to add large savings. And I'm actually going to share that spreadsheet with you. So hopefully you can all now see that spreadsheet. So this applies even more as you go down in speed. So if, for example, we can reduce our speed to 80%, we drop that to 17,000 or £18,000. So our saving increases to 17,000, and our payback time in months reduces to 3.4 months. So certainly anything, you know, in asphalt plants, you have exhaust fans, and wash plants, you have a lot of pumps, things like that. If they are needing 100% capacity, then you can't slow them down. There's nothing we can do. You need that capacity. But if something is running faster than it needs to be, if you can get enough airflow, or you can get enough flow from the pump while running that at 70-80%, then there's a huge energy saving to be had here. The other thing that you can do is you can automate that energy saving. So you can, I'll just go back to my PowerPoint here. You can, if you have a pump, for example, you can put in a pressure transducer to make sure that it's getting, or a flow meter to make sure it's giving you the flow you need, and then feed that back to the VSD so that it will speed up or slow down to give you what you need in terms of the application, as opposed to just running flat out for the sake of running flat out. So the advantages is that there is large energy savings with a very fast payback. Putting a VSD in your motor will also correct the power factor and increase your motor efficiency. The final application speed will reduce, which could be a disadvantage. So as I said, if you need the application to be at 100%, then you haven't got a lot of choice. You need that production. Another disadvantage is it's only applicable on centrifugal loads. So if you go and have a conveyor and you turn your conveyor down, you won't be able to use the square cube law. There is other opportunities around that, but you can't use that square cube law. It can only work on centrifugal loads. Okay, energy saving opportunity 4. I said control, and that is because the control of your plant is potentially the biggest energy saving opportunity that you have. And not only that, it can also transform your production. So it can make your production better, more efficient. It's very difficult to quantify, so it can sometimes be overlooked. It's very hard for me to say, if you control that plant better, you will save X amount of percent, because I don't know how much you'll be able to slow down by, and I don't know exactly how much that will save by slowing down with that. And like everything, everyone wants results. This kind of has to be measured. So what you would need to do is take measurements beforehand, make your control changes, and then afterwards measure again and look at what you've saved. There is theoretical calculations which can be done, which I'm going to run through. So if something is running that can be done without, then the savings 100%. So that's the first thing. I have been on a lot of quarries over the years. I'm sure every single one of you, whenever you drive down into your quarry plant, you see belts running with very little coming off the end of them, or sometimes nothing coming off the end of them. And quite often, a large percentage of the power that is used in your system is actually used to drive the conveyor belt as opposed to move material. And again, everything is about the application. So your your stones here, or whatever you're processing is here, the end application is here. Everything in the middle is an inefficiency and something that we want to get down to virtually as low as possible. So if your conveyor belt is running, can be done without, there is definitely control there that can be put in to make that stop, or to make that run slower. And then even when it is running flat out, so even whenever your plant is running at what you believe to be at 100% capacity, 90% of the plants is designed with a reserve factor above that. So if you have a conveyor designed to take 250 tons an hour, the chances is that the manufacturer you've bought that off has designed that with some capacity in hand, that it can take 350 or it can take 400 tons an hour without having spillage off the side of the belt. And that means that you're turning rollers faster than required. You're moving a heavy belt around faster than required, and that all takes energy. So here on the right hand side, I've showed a graph. This graph is taken directly from our calculations, some of the selections that we do. So if I take a belt speed of 0.7 meters per second at 250 tons an hour, that belt will absorb 6 kilowatts. We would probably select a 7.5 kilowatt motor on that. So that will run at 6 kilowatts. That exact same belt, using the same tons per hour, so it's the same amount of material being transferred from A to B. It's just that you're running the belt faster, you've got a lighter load on your belt, and you're shooting the material off the end of it. You're turning your rollers faster, you're moving the belt against any skirting rubber or any inefficiencies faster. That's all taking more power. So you use roughly 50% more power, 2 meters per second. So you're going up to a rough absorbed power of 9 kilowatts. So this is theoretical, but it is pro rata. So you do use a lot more kilowatts. So I've linked this through to our calculations here. This is one of our calculations that we do for selecting our conveyor. So on this, I've used a 20-meter conveyor. I've used an angle of 10 degrees, 1,000 wide belt. I've used 250 tons an hour. In here, I've used 1 meter per second. I have some belt capacity factors, idler friction factors, and a conveyor inertia G factor. So this is what we do day and daily for our manufacturers in selecting this. And as you can see there, the absorbed power requirement for that at 1 meter per second is 6 kilowatts. The absorbed power at 2 meters per second is
David,
9 kilowatts.
Sorry, just to disrupt a second. You're not actually linking through to the sheet. I know you clicked on it, but we're not seeing the sheet.
Oh, sorry.
Okay.
Okay, hopefully you can see that now.
Yep, perfect.
So on this here, this is one of our selection sheets that we use day and daily for a lot of our manufacturers. So we have our conveyor drum center distance, so 20-meter conveyor. We put in all these values, and as you can see there, we've done 2 columns here for comparison. On this side, 250 tons an hour. On this side, 250 tons an hour. 1 meter per second, 2 meter per second. Every other bit of detail is the same. The absorbed power here is 6.61 compared to 9.06. So as you can see, there's a huge saving there. And if you look here, this is the peak capacity from the density. So we've used 1,500 kilograms per meter cubed. So that's telling me that conveyor at 1 meter per second could take 562 tons per hour without it spilling off the sides. You know, that's actually the capacity of the belt. When we run that at 2 meters per second, you could have, I'm not saying we would have the torque or power to move that capacity, but I'm saying that's what the belt could hold. So when we go at 2 meters per second, that can hold 1,125. So this is what we do when we select the speed of the conveyor, and we try to select the speed as close to what's required. But what often happens is if your manufacturer is manufacturing your plant and he wants to make either standardize it that it can do 150 tons an hour or 400 tons an hour, he selects quite high belt speeds. And that's just wasting energy. So what we want to do is, on this conveyor here, for example, if I was working on that, I would want to reduce that down to something like 0.6 meters per second. It gives me a nice reserve factor to make sure my belt's not going to be spilling over, and it drops my power right down to 5.63 kilowatts. Just shoot back to the presentation. So that is something that can be done in retrospect. So even though we're talking about theoretical calculations here and designing the conveyor out as a start, I realize a lot of your conveyors is already going to be sitting on site, already been selected, already got the gearbox on it that's on it, the motor on it that's on it. So what we can do is we can use VSDs to slow them down. And it means that it doesn't have to be a permanent fixture. If you put a VSD on that conveyor and slow it down, you will get that saving. So the motor will only use the power that it's going to use. You could reduce the size of the motor, possibly. So if you put a VSD on it, slow it down, and you're using an awful lot less power with the slower speed, you could then look to reduce that size of motor, which will give you another efficiency saving. But again, like I said about your pump, you can use a PID system and you can make that automatic. So what you could do is put on a VSD and feed back into that VSD from a current sensor, possibly from the drive itself, possibly from a little level controller on the conveyor. We do now radar sensors, which are very, very good, very, very reliable and cost effective. And we could accurately sense what's on the belt. And basically, if you've got an empty or a very low amount of material running up the belt, then the VSD can automatically slow down. So we just set a target for, we don't want to run this belt faster than it needs to. So you set a target of, I want a bed depth of 20% or 30%, whatever it is. If it's lower than 20%, the conveyor will slow down, so that builds up. And then if it's higher than 20%, then the conveyor will run faster to make sure it's clearing away the load. So we have done this. We've done it as a case study. It was very, very successful and worked. The downside is you have to buy a VSD. VSDs, they're expensive, but it doesn't require big mechanical changes, and the VSD brings several other opportunities to your system. So advantages, disadvantages. Sorry, there's one other thing that I wanted to point out is whenever we do our calculations, I meant to point this out when we were in the spreadsheet, but we have an angle of inclination for like stockpile conveyors, things like that. And while we look at the friction factors of all the conveyors when we calculate them, one of the big things in the calculation is the work done. So it's the work done to move product from here to here, and it's the height that has to move that product up is a huge contributor in the energy absorbed. So if you look at, I have conveyor incline in degrees here on this graph, and obviously again same conveyor, 20 meters, 250 tons an hour. For the incline that up conveyor up at 10 degrees, you're looking at 6.5 kilowatts. At 25 degrees or 22.5 degrees, you're looking up above about 9.5 kilowatts. So again, and I know some of the mobile machinery does this where they can lower the conveyor and only move the material up the height that you want it. But on some of your stockpile conveyors, if it's a permanent fixture that you have a ridiculously high conveyor and the stockpile never gets up to the face of the conveyor, then there's a possibility you could look into lowering that, because everything you do around that, every bit you lower that down, you're saving energy. So the advantage is this: when you put a VSD on, obviously you also reduce the amount of wear on all the mechanical components. You're rolling them rollers all around much faster. They're all wearing. Your gearbox is wearing. All that energy is going somewhere. Energy can't be made or destroyed, only transferred. So your belts, your skirting rubber, you're basically wearing everything faster. That better control can result on the plant being easier to run, less breakdowns, and you can also add in automation as you do that to reduce the amount of interference by manual operators. It's better mechanical sympathy and less wear. And I'd say one of the biggest downsides of this is it's something that I'm quite excited about, and I think is one of the best energy saving opportunities. However, it is hard to quantify. It's very, I could come on site and do a survey to say, this is all the improvements we could make. This is the theoretical amount of energy that we could save, but it is hard to quantify. It needs measurements beforehand, do all your things, and then measurements afterwards. Okay, last one is our jaw crusher auto unblock save system. And this is both an energy saving opportunity, but it's a huge efficiency saving in terms of production, which is, to be honest, the main place that we aimed this project. It didn't start out as energy saving, it's mainly efficiency saving and increasing your quarry's efficiency. So recognizing the health and safety risk and the significant loss of productivity that a block jaw crusher poses, we developed an industry-leading, energy-efficient automatic jaw unblock system. And again, using a VSD, we use intelligent functions to clear blockages from a static position using forward and reversing moments and applying a range of program parameters to remove the risk of manually unblocking jaws. So basically what we do is when your jaw is sitting blocked, stopped for many reasons, it could be power failure, it could be emergency stop. We all know several reasons a jaw can block. We basically rotate it one direction, that the flywheel is moved into its sort of 3 o'clock position, and then we rotate it the other direction to the flywheel's in the 9 o'clock position, and we just use the moment of the flywheel and intelligent software to sense where that is, sense the current, sense the DC bus voltage in the VSD, sense the torque, and sense the speed. And we decide when to inject power in one direction, inject power in the other direction, and we continue to rock back and forth until we break through, and then the system basically starts up and gets the jaw unblocked. So it's been a very, very successful system for us. We have a video and stuff that James will drop into the chat, and I'm going to run through a little bit more. So we've done a very quick comparison. This is obviously different for every quarry. Some people may be fantastically brilliant at unblocking their quarry with a jackhammer. Some people, it depends on the rock, it depends on lots of things, but typically some of the surveying that we done talking around quarries, the average time lost, we're looking at 240 minutes, which for unblocking it using jackhammer, winching stones out, that could be up to a day, it could be much more, it could be much less. The unblock system, we've put in a time of 5 minutes. Basically, you identify your jaws unblocked, you press auto unblock, it will start doing the unblock system. So we've put in theoretical throughput, lost time. It's a huge saving in terms of the amount of tons that you lose through production, but also the health and safety aspect of it, the fact that no one has to go in there, winch out stones, no one has to go into the rock breaker and break out rocks. There's a huge saving there. So we have designed this control to go into primary jaw crushers in quarry and mining sector. It can be used on static or mobile plant. It can also be used on mobile plant. However, it can be a little bit more difficult to put into mobile plant because of space constraints. in terms of mounting a VSD in a mobile machine. We have been involved with a lot of diesel electric machine manufacturers here in Northern Ireland, and they all mostly incorporate it from the start. So any new hybrid electric jaw crushers that's coming through from any of the manufacturers should have this system on it. But on an old machine that typically didn't have one on it, it would be hard to retrofit. Jaw crushers in static applications are traditionally driven by slip ring motors with assisted starting via conductive starters. So it can be used on any three-phase motor, 380 to 460 volt supply, 50 or 60 hertz. It can be used in conjunction with standard AC synchronous electric motors up to 355 kilowatt, 2-pole, 4-pole, 6-pole, 8-pole. It will replace star delta starters, replace soft starters, and replace slip ring starters. So slip ring motors were traditionally used on jaw crushers because of their very, very high starting torque. And a slip ring motor, whenever it's at speed, has the same torque or the same properties as a standard AC induction motor, only with a lot less efficiency. So if you have a slip ring motor, or sometimes called a wound rotor motor, it starts with a very low inrush current. It puts resistance into the rotor circuit, and as the motor accelerates, that resistance is decreased. As I said, the torque is very, very high, and that is why it is used on jaw crusher applications, because of that starting torque. However, they don't have a forward reverse function, so even though it in theory has a higher starting torque than a VSD, but it doesn't have that control. So our system focuses on using the jaw crusher's own flywheel weight to break through. So it just uses an intelligent way of deciding when to apply power to it, to use itself to unblock itself. Slip ring motor is very popular in crushing applications, but excessive manufacturing cost and expensive starter requirements have limited the use on modern applications. So they're not traditionally used on new jaw crushers that's coming in. A lot of people still have them on their old plant. They still repair them. I guess my appeal is they're very, very inefficient to start with. They're going to be much lower than IE1 efficiency. So if they have wearing brushes, which do need replaced and they do need serviced, and they have very large slip ring starters, which again can be unreliable. So by changing that to a modern AC IE4 synchronous motor, you massively increase your efficiency. And then adding the VSD for control, you can then get all the advantages of the higher efficiency and the higher efficiency for your quarry as well in terms of your production. So not just energy efficiency. So the disadvantage of slip ring starters, they're outdated technology and only produced by a handful of manufacturers. They are expensive to replace in comparison to synchronous electric motors. They have high maintenance costs. Inspection of wear parts is required frequently, and there is limited protection to the motor compared to modern electronic monitoring methods, and poor availability. The other option we have for starting a jaw crusher is star delta. There's disadvantages to that, and star delta is very poor starting torque. You have limited control in terms of forward and reversing and having information back from the motor, and you have limited protection for the motor in comparison to a VSD would have much better protection. The disadvantages of soft starting is there is reduced starting torque and there's limited control. So there's much less starting torque with a soft start as opposed to VSD, which is why we opt for VSD in jaw crushers. So I think I've pretty much covered all these, but I'm going to run through them again. Is just some of the advantages is a significant reduction in downtime. It completely removes the need for anyone to go into it. So it's a significant safety risk removed. It has increased motor protection. it is an increased warranty if you put a VSD with the motor, as I said before, you get your 3-year warranty. And it can be used with almost any existing AC asynchronous motor. So you don't need to replace the motor in order to put this system in if you've got an AC asynchronous motor in place. If you had a slip ring motor, we'd be advising to replace the motor as well at the same time. And there's a reduced mechanical stress on the transmission. So because we're rocking back and forth, we're not starting with one just big high torque and trying to drive through stone. So there is reduced stress on your mechanical transmission, and there's a reduced surge on your power supply. So it is the VSD, because it controls the current, there is a reduction on your power supply. That's a typical layout of the one of the panels that we supplied. It's very, very simple. It's simply a VSD and a panel with a little bit of control. There's not an awful lot more to it. That's just our little HMI screen, which whenever the unblock mode's pressed, inside the firmware of the drive, we have brought up certain messages, so it will only try to rock back and forth a certain number of times. There's certain alarms, lots of stuff built in there, but it will give you feedback to let you know what it's doing. And then lastly, whenever we supply this package, we supply it with a remote access support package. So we supply it and try to support everything as best we possibly can. So in this, we can connect into the system. We have got unattended access. We can change parameters. It gives you free remote technical support for faults. We can also log faults. So you may have had a fault yesterday. You'd like someone to log in and check it out. That all can be done. There's also lots more can be done through that, in that if then you decided there was some sort of nice control that you would like to add, that can be added into the software remotely. So yeah.
Yeah, perfect.
This system we have developed basically unblocks our crusher from a static position using forward and reverse in action, using several parameters, including current, speed, DC bus voltage. I just want to talk through some of the advantages that this system brings to quarry operators. As most quarry operators know, it's a major problem when a jaw crusher stops full of stones. It requires a jackhammer or a winch or someone to manually go in and remove stones out. This system completely automatically goes forward and reverse to remove them. It is a major advantage for health and safety because no operator needs to be near the crusher when it's done. It's done by simple press of a button. The system does completely automatically, and then whenever it's ran free, it gives the unblock complete signal. Another advantage is the protection of the electric motor and the jaw itself. Because we are monitoring so many parameters, we offer a much superior protection over traditional methods, and that can increase motor life and equipment life. For that reason, we can also upgrade the warranty to 3-year warranties on inverter and motor. And the last major advantage is time. As we all know, time is money, and the time aspect with unblocking a full crusher can be astronomical. So this system, normally within 4 to 5 minutes, the crusher's fully functional again and running clear.